Hello, this is part 3 of a video where I looked at the correlation between the variate values and corresponding ranks. And for part 3, we're going to illustrate this in R. Part 1 of the series, we looked at driving the theoretical formula for the correlation between the variate values. So if we take a random sample and then rank that random sample and then find the correlation between the two. This is the general formula, and that's in part 1. Now, part 2, it was noted that this expected value here is really the tough part of this formula to figure out. So if you're generating data from a sample or a population called F, you can usually drive the standard deviation, you know the mean, and all the other values are easy. But this expected value of X times the CDF of X is pretty complicated. Well, can be, not always. And in part 2, that's what we dedicated the video to, was deriving this expectation for specific cases. And we learned that the correlation between variate values and ranks in a normal distribution is 0.97, uniform is 1, exponential is 0.86, logistic is 0.95, and these are the asymptotic results. And we also gave actual results for any sample size. Here we're going to take samples of size 1000. Which is here. We're going to create a 2-row by 1-column plot area. Here we're going to sample from a normal distribution. And if we look at the histogram of what we have, so X is we're sampling from a normal distribution. Y is the corresponding ranks. Of course, this looks normal-ish. And the ranks will always be uniform because it goes from 1 to 1,000 and it's uniformly distributed. So it's always going to be uniform. And when we look at correlation, so back here, whether it's positive or negative is really based upon this inner piece right here. So if the values are less than the mean or greater than the mean, on both X and Y, determines whether you have a positive correlation or negative correlation. So in the plots that are coming up, we're going to look at the mean of these. Of course, the mean of the Y will 100% always be the same, but the mean of the sampling distribution will not. In the normal case, it's pretty symmetric, so half the data will be below the mean, half the data will be above the mean, same way for its ranks. But if you have a skewed distribution, that's not the case, which is going to throw off the correlation. So let's get back to the normal curve, and here we're plotting the variate values versus its ranks. So if we were to take these values and shove them straight down, it would look like a normal distribution. Notice that the majority of them between -2 and 2. If we were to take these values and shove them to the left, it's going to be an exact, uniform distribution. So let's look at the regression line, is the red line there, and the black crosses are the sample means. So notice the regression line doesn't, the data is not perfectly linear, but it's linear-ish. It's a high correlation. And when this data here are below the mean here, they're below here, and they're above and above. So the correlation is 0.98. And now let's look at the exponential distribution. So the exponential lambda 1, this is it. So it's a highly skewed distribution. Majority of the data is going to be sampled from here, which is, in this part here. And then notice it's more sporadic here. So when we look at the least squares line, it's here. So there is a positive correlation. It doesn't seem to be very good. When we look at the respective means of course this mean will never change of the ranks, but this one does. And notice that this data here is, it's below the mean and below the mean, so that you get positive values for that. But here you're above the mean here but below the mean here. So those are going to be negatives. So a lot, when you're adding these up, a lot of those negatives cancel with the positives. And here, they're above the mean and above mean, so you get positive. So the correlation is 0.886. Let's look at the uniform distribution. It's not very exciting, but it's kind of cool in that fact that it's not very exciting. So the distribution of a uniform 0, 1 is, it's constant from 0 to 1. And if we look at the random sample versus the corresponding ranks, this is what it is. And that's pretty darn linear. And the mean, they're all below and below and above and above. And so the correlation's really close to 1. Yep, 0.992. Now let's look at a logistic curve. Here, it's kind of normalish, and the tails are much fatter. So when we plot our data versus the ranks, we get something that looks like this. You're going to have a lot more outliers, and so the regression line is it's not going to fit it as well. But the mean being below the mean in both cases is true, and above, but it's not linear. So here the correlation's 0.96. But now let's look at something that's highly skewed. We're going to look at a log normal distribution with a standard deviation of 1 here. So let's plot it, and this is the case. So this is highly skewed. So most of the data will be here, which is here. Now let's fit the regression curve, and so notice again that there's a piece here that are above the mean, for the ranks, but below the mean for the variate values. So those are going to, and there's a lot of them, so they're going to contribute to canceling out some of these others that are positive and positive. And so here the correlation is 0.75, so you can see that. But out of fun, let's change this to 2, which makes it even more skewed, and redo this. Sample 1,000 from the log normal and then plot it. And here, and so this is roughly the distribution. So all of it's going to be, the mass is going to be right here. And you can kind of see that all the data is here. But there are a few out here because it's a highly skewed distribution. So when we fit the regression line, which is here, and then we look at the means, here there's a lot of data that are below the variate, the expected value of x, but are above the mean of the ranks. So there are a lot of negatives there, cancel with a lot of positives here. And so the correlation is going to be pretty low, and it is 0.3, 0.865. Now if we were to make this even more skewed, I think this would be a little bit even more closer to 0. I don't know if theoretically we could get it to 0 or not, but anyway, that's all I have to kind of give you an intuitive feel for the previous 2 videos. Hope you enjoyed it. I sure did, and we'll see you later. Thanks.